Hey guys, how was your balancing? I hope you did a good job. If you have any questions, it's okay to come and ask. Now we're going to use this balancing to do something called mole ratios. So we're going to change up our fences a little bit today. We're going to learn how to do something that's called stoichiometry. And so here's what stoichiometry is. It allows you to calculate amounts of different substances in a chemical reaction. So think about this. If I decide I want to make a cake and I look in my refrigerator and I have 11 eggs, but I know that each cake takes 3 eggs to make. I would want to know how many cakes can I get out of my fridge. I really, really want some cake. And so stoichiometry is the same thing, but instead of eggs and cake, of course, we do it with chemicals because it's chemistry. This calculation is going to be done with something called a mole ratio. So we're going to convert moles of one thing into moles of another. And so if you have your mole island paper handy, it might be a good time to get it out. We're going to learn a new island. We're going to use coefficients that you just found in your reactions. Okay, that's why you have to be able to balance. Those coefficients are going to appear in your fences. So everything that you see today, because it's a mole ratio, we're going to go from this mole island to this mole island. And so you'll see on your paper, it says you're going to use coefficients. When you do that, that is creating the actual mole ratio. So you might want to put that on your paper as well, so that you know when you're going between those islands, okay, the thing between mole and mole is called a mole ratio, and it will use coefficients. So let me show you what I mean here. Hopefully this is what you have for the first balanced reaction. If you got something different, either figure it out or come talk to me about it. Let me know what we can do to help. So the good news about this is whenever you have moles and moles in a question, notice that they're right next to each other. So these mole ratio fences are only going to be one step. Yay, nice and short. Okay. So if I look in the question, notice that you see moles and moles. Moles, 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 moles. That means mole ratio. Okay, so we're going to set up our nice one-step fence, and you're still going to start with what you're given, 2.59. Here's the problem with this. If everything is mole and I just write mole all over the place, your fence isn't going to get anywhere and it's not going to do what you want to do. So we're going to have to make this one a little bit different. So draw my fence. I got 2.59. In order for us to tell the difference between these moles, what you're going to have to do is look at the chemicals that go with them. So this is 2.59. Get rid of that. 2.59 moles of oxygen. So look up in the reaction, oxygen is this thing. So I'm going to use that in my fence instead of writing the word mole. So you have to pay attention to both of the units, okay? Then you're going to see that it's up, and we know that that's going to go down. That's fine. The other chemical that I want is this one. That's the thing that I'm looking for. That goes on top, just like always. Now, because you have chemicals next to each other, you're going to use the coefficients that are next to them. So this is why you had to balance, was to get these numbers. So if I look for this chemical in the reaction, the coefficient in front of it is 2. And so that's what I'll put next to it in my fence. If I find oxygen, this is the coefficient next to that, and so I put it down there in the fence. And then you can put this in your calculator just like normal. Remember to times on the top, and then go ahead and divide down. So go ahead and plug that in. Times 2 divided by 3. And my calculator has this funky number, 1.7266666 something 7. Sig figs are still going to apply. Over here I started with 3. The third sig fig is here. But this 6 is going to make the 2 round up, so my final answer will be 1.73 moles, and you can put the chemical if you'd like. I'm more concerned that you write moles, but since you have the chemical here, it is really easy to put it in your answer. All right, is that kind of weird? Let's try another one. Let me make sure that you're really comfortable. I see moles in the question, and I see moles. Whenever you have moles and moles, look, they're right next to each other here. So set up your single fence. I'm going to start with the number that I was given, the 34.0. But remember, since everything is moles, you can't write moles in your fences. It doesn't make sense. We can't all be moles. We're going to tell them apart by their chemicals. So this is moles of this thing, Fe2O3, which means I'm going to put it down. The chemical that I want is moles of Fe. That goes on the top. Now find the coefficients for those from your reaction. Fe, whereas it has a 4 in front of it, so I put that in my fence. Fe2O3 has a 2 in front of it, so I put that there. All right, throw that in your calculator. Remember to times on the top, divide down. All right, so go ahead. My calculator says 68. Then let's check our sig figs. This original number has 3 sig figs in it, but right now we only have 2. To get it to the 3 that you want, you can just add a 0.0, and your unit will be moles. Everything is moles today, and the chemical we were looking for was Fe. All right, if you're feeling good, you go right ahead, use your balanced reactions, see what you can do with mole ratios on this page. Come back at the end of the video because I'm going to give you some hints for your homework, okay? If you're still not super comfortable with this, I'm going to walk through all the rest of these questions and help you out, all right? So notice that I've got my balanced reactions here. You have to do that first to help yourself, okay? So if I look at number 1, I've got moles and I've got moles. So that means I need a 1-step mole ratio. So I start with 2.5. Remember, you're not going to write moles in these fences. You're going to use the chemicals. So nitrogen is this thing. That's what chemical I'm going to use, okay? If it's up, it's going to go down. And the chemical that I want, it says how many moles of hydrogen. If you're not sure what hydrogen is, that's here in the reaction, and that's what goes on top. All right? Now, because you've got chemicals in here, I want you to use the coefficients. So H2 has a 3 in front, N2 has a 1, and then you're ready to put it in your calculator. Remember to times on the top and divide down. My calculator says 7.5, and then we just have to check sig figs. I started with 2, I've ended with 2, and so your answer is 7.5 moles. Again, if you want to add the chemical that it's moles of H2, that's okay. You don't have to, as long as you get some sort of unit on that number, okay? What I don't want you to write is don't do this, 7.5 H2s. That doesn't make sense. So you have to tell me moles. It's optional if you tell me the chemical, okay? Let's try another one. Next question, I see moles and I see moles. That's a 1-step mole ratio. So start with the number you're given. I got 6.0. Oh, that's a terrible 6. Hold on. Okay, that's better. Remember, because this is all moles, we are not writing the word mole in our fence. We're going to use chemicals. So the thing that I started with was moles of this thing, KClO3. It's up, it's going to go down. Then I want moles of oxygen. This is the symbol for oxygen, so just use it. You don't have to figure it out. Now match up your coefficients. O2 has a 3 next to it, KClO3 has a 2 next to it, and then you're ready to put it into your calculator. Remember to times on the top and divide down. Times 3 divided by 2. My calculator says 9. Sig figs, this has 2. To make this have 2, we can just add a 0.0. Moles, an option is to add moles of O2. All right, how you feeling? If you're good, go on, keep working. If you need a little more help, hang around. Okay, next question, I see moles and I see moles. We're going to set up a 1-step mole ratio for that. I have 3.2 moles, but I'm not going to write moles in my fence. I want the chemical. So it says moles of zinc with HCl. They have 2 chemicals next to that number. Don't fall for their trick. This doesn't matter. See how zinc is really, really close to the number? That's the chemical that we have, okay? This piece doesn't matter. All right, if it's up, it's going to go down. I want hydrogen. Here's the symbol for hydrogen. That's what we're going to put in. Put in your coefficients. Your calculator should say 3.2. I started with 2 sig figs. I'm ending with 2 sig figs already, so it's 3.2 moles of H2. All right, next question. I see moles and I see moles. So we're going to set up a 1-step mole ratio. I start with 4.8. If you make this mistake, it's going to mess you up. Don't write mole like that. Instead, oh, I erased the whole thing. 4.8. The chemical that you have is propane. Oh my God, what is propane? Remember, things that end in ane are organic. They have C's and H's in them. That's this thing. This is propane. If you're not sure of how to do that, that's what I taught you on page 6 last class. You go ahead back there and you look, okay? We just need to know the chemical for here because it's going to go up and then down. I want moles of oxygen. So oxygen is this thing that goes on top. Pull in your coefficients. All right, go ahead and put this in your calculator. And mine says 24. I started with 2 sig figs. That has 2 sig figs, so it's 24 moles of oxygen. All right, you're getting there. How you feeling? Check it out. We got moles and moles, so we want a 1-step mole ratio, okay? I start with 21 moles of that chemical. It's up. It's going down. I won't sing you the song. KNO3 is the chemical that I want. So now I just have to use my coefficients. KNO3 has a 3 with it. K3PO4 has a 1 with it. So now we're set to put this in our calculators. Mine says 63. I started with 2 sig figs. Let's end with 2 sig figs as is. So it's 63 moles of KNO3. All right, a couple more. Next one, I see moles and I see moles. That means 1-step mole ratio. So I start with 18. Don't write mole, look for the chemical, KBr. Okay, if it's up, it's going down. I want this chemical, so that's the thing that goes on top. Then use your coefficients. AlBr3 has a 2 in front of it. KBr has a 6 in front of it. Now you're set to put that into your calculator. Times 2 divided by 6. My calculator says 6. But I want 2 sig figs. So to make this 2 sig figs, I'm going to add a 0.0. And it's moles of AlBr3. Again, optional to add the chemical. Good either way. Okay, I can see the end. We're almost there. I see moles and moles in this question. Okay, set up your fence, 1 step. 6.4 moles of H2O. It's up. Move it down. I want H2. That goes on top. Find your coefficients. H2 has a 2 in front. H2O. Oh, what did I write? Oh, I put an extra O. Sorry, guys. Do over. The chemical at the top that I was looking for should have been H2. Okay. So H2 has a 1 with it, now that we have the chemical, right? H2O has a 2 with it. So you see it's important that you write those chemicals correctly. Then you can put it in your calculator. My calculator says 2.82. 3 sig figs. It's already got 3 sig figs, so you're set there. All right, couple left. I see moles. I see moles. So that tells me I'm just going to do a single mole ratio. I start with 17. Don't write moles. SO3. Up. Down. I want O2. That goes here. Use the coefficients you balanced. O2 has a 12. SO3 has an 8. Go ahead and put that into your calculator. Oh, I'm going to push it right. 17 times 12 divided by 8. Mine says 25.5. This has 2 sig figs, and right now we're sitting at 3. So I'm going to end my number here, but this 5 is going to make it bump up, so your answer is going to become 26 moles of O2. All right, last one. I don't know what this is. That's an arrow. All right, we have it balanced. My question has moles and moles, so let's set up our single mole ratio, okay? We start with 43.0, and the chemical is carbon dioxide. If you're not sure what chemical that is, find it in here. What thing has carbon and oxygen in it? That is carbon dioxide. It's up, so it's going to move down. I'm looking for water. We all know water. Now use your coefficients. CO2 has a 6. H2O also has a 6, so put that in your calculator. The answer my calculator says is 43, but this has 3 sig figs. So to make this have 3 sig figs as well, we put a 0.0. This is moles of H2O. All right, here's the tricky part. On your homework, some of the things are one step, like we learned a long time ago, where it would just be like this, the very first fences you ever learned. Some of them are 2 steps, like we learned last unit, where you get your bigger fences. But then some of them are going to be like what we just learned, which is a mole ratio, only 1 step, but now you would use chemicals in there and coefficients. So I'm going to walk through a little bit with you how to figure this out using your mole map. I'm not going to solve them, but I'm at least going to help you decide which of these things you're doing. Okay, so flip to the next page with me. I'll give you some homework hints. All right, so this is the balanced reaction. You're welcome. Look at this question. I see grams and I see moles. So grams is here, moles is here. That means this is a regular old one-step question, right? I can go from there to there in a single step, not a problem, okay? So that's the old, very first fence you ever learned, okay? If I look at the next one, then I see moles and I see moles. That means I'm here and I'm here. This is a mole ratio question. You're going to do moles, moles. You're going to put your coefficients in there like we just learned. So this is new. Okay. If I keep going, cover up my answers so you don't look yet. Okay. Next one, let's check out the islands that we see. I see atoms and I see moles. Remember, down here on particles, you can have atoms, you can have molecules, or you can have formula units. So we're starting here. We want to get to mole island. That I can do in a single step, so this is also a one-step question. Okay. Lastly, let's do one more together. Look at this question, things I see in there. I see formula units and I see grams. Remember, formula units we said was down here. Grams lives way up here on mass. You can't go straight like that. That's not how the fences work. But what I can do is go from here to here. So this is what we learned last unit. This one will be a 2-step question. All right, I hope that helps. I want you to work on this page, ask any questions that you need to. You're going to be a mole pro.